So, right, this is an additional little thing for the higher. I think it's lesson 14 is 3D Pythagoras. Right, okay, so we've all done the 2D Pythagoras by the time we get to this one. And so what we're going to do is have a 3D shape, a cuboid, and I'm going to draw it like that so that we can see through it. And in there will be a line that goes from the bottom left hand corner up to the top right. Bit difficult to see, but yeah, there you go. Bottom left hand corner up to the top right. We've got to find the length of that diagonal line. So you get, say it's 4 and 10 and 2 or something, some dimensions on the box. So you can do it in two ways. So the first way we're going to do it is we'll make a diagonal line that goes across the bottom of the shape, and we'll call that A. So with Pythagoras, because we've now got a right angled triangle at the bottom of the box, we can go 4 squared plus 10 squared equals A squared. Oh, this is a bit psychedelic, isn't it? 16 plus 100 equals A squared. So therefore A squared is 116. And so the square root of 116 equals A, which is, let's get the calculator out, square root of 116 equals 10.77. 10.77 equals the A. Now, to find the D, the diagonal that goes from the bottom left to the top right, we've now got a right angled triangle like this. So now A squared plus the 2 squared, the height, equals D squared. Now we know what A squared is, don't we? It's 116 plus 4 equals D squared. And that's 120 equals D squared, and the square root of 120 will equal D. So the square root of 120 is 10.95 equals 10.95. Okay, now we can do this a slightly quicker way. Is just by going 4 squared plus 10 squared. Yeah. Now the 4 squared plus 10 squared was that bit, wasn't it? The 116. And so if we use that 116 that appears in here, yeah, we can just add the 2 squared onto the end. So 2 squared. So we've got 16 plus 100 plus 4, which equals 120. And the square root of 120 is 10.95, just as we did right down the bottom there. So that's how to find the length of that diagonal line using 3D Pythagoras. The other kind of shape that you might get, and they often use this in conjunction with trigonometry, but here we're just dealing with Pythagoras at the moment. So we get a pyramid shape, and they always tell you that it's a square-based pyramid, and that tells you that all the sides are the same. So we'll make that 8 and 8, and they give you the slope, the sloping side. We'll make I don't know, 12, something like that. Yeah, and we've got to find the height. Height. Okay, so how can we do this? So let's have a look. So the height is going to be dropping down from there, and it's going to drop into the middle of that shape there. So let's draw a diagonal line across the base, and then we can work out the length of that diagonal line. So we can go 8 squared plus 8 squared equals the diagonal squared. 64 plus 64 equals the diag squared. So that's 128 equals the diag squared. So the square root of 128. So the square root of 128 is equal to, I'll just call it 11.31, 11.31037. Yeah, so this is all the way across the base. Now we've got a right angled triangle here. We know the slope, we know we can work out what half of that is, and this will give us the height. So so if we take the 11.3137 and all the rest of it, try and keep it as accurate as possible, yeah, and divide that by 2, we get this 5.65685. That's enough numbers, yeah. So this now is the length of this one. I'll call this A, yeah, and that I can call H. So A is just that bit, which is the 5.65. Now the height is going to be 12 squared minus A squared equals the height squared. So this is 144 minus 5.65685 squared equals the height squared. Let's square that number, see what I get there. Oh, 32. 32. So 144 25, this is 32, minus 32 equals the height squared. See, this is why if you put as many numbers in the decimal, it comes up to a lovely number there. So this is 112 equals the height squared. Let's come over here. So the square root of 112 equals the height. So the square root of 112 is 10.58 equals 10.58, whatever it might be, centimeters or meters or something. So there you go. So there's two little shapes that you can get with 3D Pythagoras. Sometimes when they introduce the trigonometry, you've got to find an angle in there, and you need to find A anyway, so you use the cosine to find the angle down there, but we'll do that later on. Okay, that's that one.